Hello everyone, my name is Ankit Lawade. Today is 20th of July 2022 and the topic for the today's video is IPv4 or IPv6. This is my first original video in this topic. Now let us begin with what is IP. So then IP stands for Internet Protocol and IP address is assigned to each device connected to a network. So each device uses an IP address for communication. It also behaves as an identifier as this address is used to identify the device on a network. So it defines the technical format of the packets. Mainly both the network, that is IP and TCP, are combined together. So together they are referred to as TCP/IP or TCP/IP. So it creates a virtual connection between the source and the destination. We can also define an IP address as a numeric address assigned to each device on a network. An IP address is assigned to each device so that the device on the network can be identified uniquely. And to facilitate the routing of packets, TCP/IP protocol uses a 32-bit logical address known as IPv4, that is Internet Protocol version 4. So then IP address consists of two parts, that is first one is a network address and the other is a host address. So there are two types of IP addresses, that is the IPv4 and the IPv6. Now we will see what is IPv4. So the IPv4 is a version 4 of IP, that is version 4 of Internet Protocol. It is a current version and the most commonly used IP addresses. It is a 32-bit address written in 4 numbers separated by dot. That is the period. So this address is unique for each device. For example, 66.94.29.30. So the above example represent the IP address in which each group of number separated by period is called an octet, and each number in an octet in the range from 0 to 255. So this address can produce 4 billion 29 crore then 49,67,296 possible unique addresses. So in today's computer network world, computers do not understand the IP addresses in the standard numeric format, as the computer understands the numbers in binary form only, and the binary number can be either 1 or 0. The IPv4 consists of 4 sets, and these sets represent the octet. The bits in each octet represent a number. So each bit in an octet can be either 1 or 0, and if the bit is 1, then the number is represent will count, and if the bit is 0, then the number it represents does not count. Now we will see the drawback of the IPv4. So currently the population of the world is about 7.6 billion, and every user is having more than one device connected with the internet, and private companies also rely on the internet. As we know that IPv4 produces 4 billion addresses, which are not enough for each device connected to the internet on a planet. Although the various techniques were invented, such as variable length mask, network address translation, port address translation, the classes, inter-domain translation, to conserve the bandwidth of IP address and slow down the depletion of an IP addresses. So in this technique, public IP is converted into a private IP, due to which the user having the public IP can also use the internet. But still, this was not so efficient, so it gave rise to the development of the next generation of IP address, that is IPv6. Now we will see what is IPv6. So the IPv4 produces 4 billion addresses, and the developer thinks that these addresses are enough, but they were wrong. IPv6 is the next generation of IP addresses, and the main difference between IPv4 and the IPv6 is the address size of an IP addresses. So the IPv4 is a 32-bit address, whereas IPv6 is a 128-bit hexadecimal address. So the IPv6 provides a large address space, and it contains a simple header as compared to IPv4. It provides transition strategies that convert the IPv4 into IPv6, and these strategies are first the dual stacking. It allows us to have the version, that is IPv4 and IPv6, on the same device. In tunneling, in this approach, all the users have IPv6 communication with an IPv4 network to reach the IPv6. Then network address translation. So the translation allows the communication between the host having a different version of IP. Now we will see the difference between the IPv4 and the IPv6. So first, on the basis of address length, IPv4 is a 32-bit address, whereas IPv6 is a 128-bit address. Then fields, IPv4 is a numeric address that consists of 4 fields which are separated by dot, and IPv6 is an alphanumeric address that consists of 8 fields which are separated by colon. So the number of IP addresses has a limited number of IP addresses in IPv4, and in IPv6 has a large number of IP addresses. Now on the basis of address configuration, IPv4 supports manual and DSCP configuration, whereas the IPv6 supports the manual, DSCP, auto configuration and renumbering. Then on the basis of address space, IPv4 generates 4 billion unique addresses, whereas the IPv6 generates 340 undecillion unique addresses. So on the basis of end-to-end connection integrity, IPv4 end-to-end connection integrity is unachievable, whereas the IPv6 end-to-end connection integrity is achievable. So the address representation in IPv4 is that the IP address is represented in decimal, whereas in IPv6 the representation of a IP address is hexadecimal. Then the fragmentation is done by the senders and the forwarding routers in IPv4, and the fragmentation is done by the senders only. So this is all about the IPv4 and IPv6. Thank you.